What is an operating system? In simple terms, it is the chief program that manages all of the hardware and software. It has control of every process, file, section of memory, and device. It is very important, as it works as a middleman, making sure both hardware and software interact correctly. Windows, Mac OS, Linux, and Unix are the big operating system contenders, and all have their own advantages and/or disadvantages, but they are all based off the same concept. There are 4 essential managers of every operating system, and they all work together like a team to get jobs completed. The operating system works as their boss and makes sure they are all working in harmony.
We need a scheduling policy when we have many jobs to run or we are limited in resources. It needs to solve 3 limitations of the system. A. There are a finite number of resources such as disk drives or printers. B. There are locked resources, so they cannot be shared with another job. And C. Some resources may need the user to reassign jobs. We want a policy that can deliver the maximum throughput, provide quicker responses, and ensure fairness for all jobs while also maintaining an efficient CPU service. At 3 old schemes of memory management. Single-user contiguous was the first scheme of memory management, and it wasn't very efficient in terms of performance. A single job would reserve the entire memory space. This job would be processed, and then the memory was cleared, allowing the next job to be loaded. If the job size was larger than the space available in the RAM, it could simply not be executed. What if you wanted to store 2 or 3 jobs in the memory? This is when fixed partitions came along, allowing allocated partitions to contain more than a single job at one time. All of the partitions were stored in a partition memory table to keep track of partition usage. The sizes of these partitions were static, meaning they could not be changed, unless the system was rebooted. Both fixed and dynamic partitions need some way to allocate jobs to the available partitions. There are 2 ways to do this. The first fit quite simply finds the first partition that has sufficient storage space, not taking into account how much memory could be wasted in the allocated partition. The best fit first looks for the smallest partition, resulting in more space for other jobs, resulting in slower performance but better efficiency. So, when a job has completed processing, it is then removed from memory, also known as deallocation. With a fixed partition, this is fine. It is simply cleared. But when using a dynamic partition, it gets more complex to free up memory as it tries to join together adjacent blocks. We need to find a way to avoid having to keep the whole program in memory to run and the restriction of storing the programs contiguously. What if we could divide the jobs into separate, smaller chunks? We can. Virtual memory is the solution, and we shall look at the evolution of 4 memory allocation schemes. Let us start with paged memory allocation, allowing us to divide the job into equal-sized parts. The sections of a disk are known as sectors or blocks, and the sections of main memory are known as page frames. Before executing a program, the memory manager makes some preparations. First, it determines how many pages are in the program, and then it locates enough empty page frames in the main memory so that it can pass all the pages into them. The adjacent memory blocks do not have to be loaded in as adjacent memory blocks. They can be stored in any available page frame in the main memory. Now, this is a more efficient scheme, but it does come with complications. We need a way to keep track of all the page locations, which increases complexity in the operation. How do we determine replacement of pages? By using a page replacement policy. First in, first out. Least recently used, least frequently used, and most recently used are replacement policies used to change pages based on a specific algorithm.
Thank you to all our wonderful listeners, friends, followers, and subscribers.